Hello everyone, today we are solving the diameter of the binary tree. Now the diameter of the binary tree is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. Take an example where it might not pass through the root is this one. So example, there's a tree, a skewed tree. So here we have a lot of nodes over here till n and another set of nodes here till y. The longest path over here will be from n to y and it will not involve the root node in any ways. So and next going forward is the length of a path between any two nodes is represented by the number of edges between them. Okay. So for example, here the longest path between is 4 and 3. The number of edges between them is 1, 2, and 3, and that is the output. Okay. So look at the basic intuition behind this question is at every node we'll check what is the maximum length on its left and its right. Okay. So for 1, we'll check what's the maximum length of the path on its left and on the right. So as you can see from 1, the maximum length is 1, and then 2. On the right, the maximum length is 1. So we'll then give out the sum of these maximum lengths 2 plus 1, which is equal to 3. So this is basically the intuition behind the question. And for right that we have the pseudocode right over here. If we go to the left, if the left exists, and then there's right. So if the root is null, we'll just directly return 0 because there's no length over there. And answer will be the maximum of, as I said, answer comma left plus right. And at every node, we'll return 1 plus maximum of left and right. So at every node, we'll basically return what is the maximum length either on the left or right plus the node itself. For example, if this 5 goes forward to let's say 6 or 7, the 2 over here, rather than giving left plus right, that will just be the maximum length for this node at this point. Okay. Now, if we have to go above, will basically give us the maximum path, okay, to the next node. So the maximum path, the 2 we can take from 2 is this path over here. So this maximum path will be the node itself plus the maximum of either right or the left. So here the right is 3 and the left is 1. So the maximum is 3. Hence we would push forward 3 plus the node itself, which is 1, and give 4 over here. So that is the basic assumption and intuition behind this question. Now let's discuss the time complexity of this question. Time complexity is big O of n. We have to visit every node at least 2 once. And the space complexity of this question is going to be big O of h, where big O of h tells us the maximum height of the tree. So in this case, where the maximum height would be 1, 2, 5, 6, 7. This would be the space complexity. So guys, that's it for today. Let's speak to the next one.